we are at 66. So on the x, we shift to 66 and go down by 1. So the x is good. When we are at the top there, we are good. And so there we have a shift of 66, and so less. So there we can go all the way up minus 1/3 by 1 over 3. We divide by 3. That's good. The x, so we are on the size plus 0.66 of the initial size, so it's completely shifted. Let's say over 3 as well, to not have too much outside. Of the next one, the next line will be shifted, so the width is the initial x from point single. As soon as it has the initial x, here the shifted line, in my opinion, will jump. Initial x minus this size then, and then minus this size the first time. There we are good, and so the x in that hop, 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 tack, 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 x takes initial x, and my initial x, it shifts by 0.66. Initial x plus its sizes by 2 over 3. That should be good for the shift. There is the left column that will not be filled. So we have them in the right orientation. I'll just go up one more step for height, starting for the y out f4. So the y, 2 starts. So we're not on that. We're going to be on 2 over 3. I go up one notch on a branch, actually. There you go. So that will be good, and I will fill the left part. So here we're good. For the offset on the second line and the third line, we will actually need to move back to the left. If I have an offset that's too far in the thing, my offset needs to be negative anyway. So as long as it's not negative at the start, it won't work. Let's go. Here, so this, we are starting x plus something. And as long as the starting x is greater than 0, then starting x, we will subtract the size of the area from it. And normally this time I have all the trunks that fill in. With the right alternations, if all goes well, x, it's not n, it's smooth. If I start writing non-syntactically correct Pascal, it's fine. Period, it does, and it replaces. Advise yourself. So it's messed up and messed up. As long as it's greater than 0, I remove the size from it. 0.66, 0.662, shift to the right. No, that's not it actually. So if I'm here, the previous one is at 1.2. No, it was 5/3, as we said for the height. So that wasn't it. It's the height of something, so it's the shift of an area. Actually, it's this one that matters. I've positioned one. I need to go back up to the one that's outside. That's better. Well, if you want. In any case, I have the whole screen, so that's good. Well, it's good. It's not good, but there's something taking shape. In any case, it's the colors that are no longer right. So here I have the black one with another black underneath. I'm going to put the outlines back so you can see better. The stroke here. We reactivate. There, I've positioned it correctly. It's the color that's not right. So, by the way, I'm going to set the outline color. In red, it will be more visible. 3-stroke. Color point. In T alpha, color point, red. There you go. So that's okay. However, it's the color that's not right. When we start over from scratch, so you have to remember the color you set at the beginning. White color, not offset line. Anyway, the offset line is no longer of any interest. What is it for? It is no longer useful. Yes, that's it. It's no longer useful, so we get rid of it. I no longer have any intercalation offset. I know where I'm positioned. So the white color, it's no longer, in fact, it's... So we will set it to everything for the first line. If we position ourselves here, then the next one, it is necessarily of a different color. However, if we shift again, we said here, if we shift again to the other, it actually changes color again. So we are indeed on something like this. White color, white at the start, color. White at the start. It's whole. It takes the white color at the start, and then it slowly and gradually over a period of time, eventually it changes and transforms. When we change lines, we change color. We note the white color. However, when we change lines and shift again, we also need to change the color. Begin. There, here. There you go. It took us an hour to get to, no, 3/4 of an hour to redo this, but in any case, it's good for the 3. Now, the goal of the game is to turn them. So we will take them at random in the grid, and then I will simply apply a rotation to them, and we'll see what happens. I won't do the same diagonal effect, even though I could. I'll still take them randomly like this for fun. So I'm going to remove the red. We'll put that back, and comment out the color. So I no longer have the outlines. Now we need to animate the thing. So here, F12. I am going to do that. And we will say. We were on the blacks all of a sudden and the whites after, when they are equalized. Say what? Timer anyway. It's the simplest. Here. So we need to make sure we are not spinning two crosses that are next to each other, otherwise it will mess things up. So consequently, we will have a hard time doing it, since I don't have a grid concept at the level of the decomposing itself. But we will manage, we will try something. So here I go on this key, 1 second already. I will store the information, if it is white or black on the cross itself. So when we have defined the color, cross thing fill color, here, so cross, point tag boolean, oh darn, it was no longer there. It was not available. Do we have a boolean on this or not? Your size. And if I put a button, just check something. Tag. On-stream function float and object. Ah, yes, no, there wasn't the arch yet. It's true, I missed the boolean. So, we will do it in digital template. But it should be the subject of a request on quality. I think I made one. Tech bool. Which must be lying around somewhere. Think about it right away. Da 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 da. Weird. New feature, right? Well, I'll have to snoop around. I'll make a note of it here. I'll receive it. I'll see. Hi, I'm Louis Pierre. Hi. Okay. So I'm going to store it entirely. So here, I'm on 3 course tags. It takes 0, let's say 1 if it's white, and 0 if it's black. Absence and presence of light. So we're at 0, 1. Here, it's good. So in my timer, the button, I might remove it now, so my timer here will be there. Will be there, and we'll say that we animate a certain number of one color and then a certain number of another. It's good to manage a grid with the information to be able to say if we are moving it or not. It's not a big deal. So let's say I'm just going to light something up. So here, I'm going to go on across. So 3 2 points T, radian plus approximately indeed. Here, cross, in. I will do it differently. Here, T fnx object. So B, J, T, fnx object. There you go. And so we have an OBJ that takes the value 2. We're on the children. Children tag 2, 2, 2, 2, random. Children. That, and so it's a TFLX object. Normally, there you go. If obj is gradient plus, then cross into obj as a gradient plus. There is a little beginning around. That will be good too. Obviously, I will first test if there is something to handle. Fikelpu, supra 0, then begin. There you go. So here we take one at PIF in the list. In the list, in the list, in the list, in list. Let's say that 0, 1 is for the color and the tag is for the color. And 3-point tag float. Let's say it will indicate whether it's animated or not. There you go. However, it is common to both. Okay, so if A points to the other equals 0, is it N 1? We trigger an animation on it. I will create a T-float animation. I will create an onFinish event for it, just to be able to retrieve it later. It's just a small fail even, so we're good. And so I can do a catch-rolls and remove it from the thing that added the units I need. There we go. So I add an animation manually. In my timer then, anime, ID, float, animation. There will need to be an end of animation. Then private thing stuff, procedure, end, rotation, timer, an object, the classic then. Here. Okay, next, so the timer. I create an animation. We set it to 1, so we're good there. We use animation, point, ready. Let's say the owner remains the form. My animation's parent point, like, it concerns the cross. We just retrieved the animation point. Property, name, and on the rotation. Angle. The end of the thing then is on finish. It will need to execute the end rotation. The start of animation is the current position. So currently, start from current. In the process on Tron, any end value. No, it was start value, sorry. It takes the cross rotation angle plus 90. If we are on a white one, and minus 90 if we are on a black one. So you need to have, okay, not the tag. So 0, 2 points. 1, I claim it, I copy it, I do this. 1 minus 90 Ctrl D. There you go. And so, alley thing, that's good. Alley point start. So we chose the property. We know which component we are on. We trigger the animation from the current value. We stop it from the end value. So actually we can choose not to do it. We can retrieve it directly by hand. Any.start value. It does the same. And there, normally it should launch animations for certain things. Okay. While we're at it, we triggered that. We set it to 1 to indicate there's an animation. We will attach the animation to the area in question. 3.tag object.anim. That way we can remove it once it's done. There you go. And so when it's finished, in parameters, the sender corresponds to the object we were working on. So normally it's supposed to be the cross. So if sender is irradiant, plus, no, it's supposed to be the animation itself, by the way, then cross non-RC. We are without this on the animation. It's what triggers the thing. So we have a cross and we have a friend and float animation. So it was float animation and float animation. So animation direction. There you go. Otherwise we exit because there will be a problem.